Okay, guys, so welcome back after the weekend. For anyone who tried out that derivation I showed you, I'm going to show you, well, I guess I posted it anyway, but I'm going to show you the final version. And what we're going to learn today are 6 new identities. We're going to learn the sum and difference identities. So I'm just going to hand them to you. I'm going to give you what those identities are. I'm going to show you a couple places that we'll use them this year, really just getting comfortable with them. And next year in calculus, you're going to see them a little more often when it comes to derivatives and things like that, where you'll need them. So, in this lesson, what I would do is you don't have to memorize these. I'm not so concerned about that. The memorization will come with time. Put them on your index cards if you're starting a collection. We have those first, I think it was 15 that we've learned so far that hopefully you are pretty comfortable with. Add these 6 to your pile, to your collection, save them for next year. We're also going to be going back to our exact values. So sine of pi over 4, cosine of pi over 6. I'm going to throw some degrees in there as well, just to make it a little easier for you. There's a note sheet that I have that you can print up and take notes right off of that if you have access to it. If not, just do it on your own paper. But again, I'm not super worried about you having all those exact values memorized from our, our 30, 45, 60 triangles, right triangles. So take your old chart out, whatever way you memorized them before. Just have that in front of you. You don't have to have everything off the top of your head. But those things are going to show up a little bit again this next couple days. All right. Anyway, for those of you who did enjoy that derivation and want to try another one, um, you can also derive the cosine of a plus b, which is here. And to derive cosine of a plus b, we're going to use the cosine of a minus b that some of you may have done over the weekend. All right, so you can pause. You can try this out on your own. I'm going to get right past it. I don't want this video to be too long. So here are our identities. So there is the cosine of a minus b and the cosine of a plus b. I'll just kind of talk about them for a minute, and then when you get to copying down, you can just pause the video and write them all down on your own. So to expand this, what this is not equal to, this is not equal to the cosine of A minus the cosine of B. That is not what these identities are. The cosine of A minus B would say, for example, like we're going to do this in a minute, but let's say I want to find the cosine of a 15-degree angle. That's not one of those exact values that we know, but we could rewrite cosine of 15 as the cosine of 45 minus the cosine, we could rewrite it as the cosine of 45 minus 30. So it's not the cosine of 45 minus the cosine of 30. The cosine of 15 can be written as the cosine of the quantity 45 minus 30. And what these formulas allow us to do is to take this cosine of A minus B pattern and expand it out. Okay? So the cosine of the quantity A minus B, A and B are angles. We can break that out to cosine A, cosine B, plus sine A, sine B. All right, I'm going to throw a lot of these at you now. You don't get overwhelmed. You don't have to memorize them all right now. Get your flashcards out. Get a piece of paper with a bank of these all out in front of you. Cosine of A plus B, you can see it there in front of you. So the cosine of A plus B can be broken into cos A, cos B minus sine A, sine B. So the way I remember it is the cosine, these signs change, but the actual functions kind of stay together. All right, so cosine of A minus B is cos A, cos B plus sine A, sine B. So pause if you need to write these down. Here's my signs. For the signs, notice the sign stays. So the minus stays a minus. So the sine of A minus B, you can see, can be rewritten there. Those are identities. And there's our tangent identities. All right, so again, the A and the B's are angles. So the tangent of A minus B is tan of angle A minus tan of angle B over 1 plus tan A, tan B. And there are your 6 new identities. So pause, rewind if you need to. I'm going to skip ahead just for time's sake. So if you want some practice, I'll do 1 or 2 of these right now for you, but what we're going to need to do is to use these, to expand them. So the sine of x plus y, they could be a's and b's, they could be x's and y's, they could be actual angle measures, but the sine of any two angles added together, so the sine sum formula, we can break it out like this. So the sine of x plus y becomes sine of a, so we kind of think of this as our a and this is our b. So we have sine of our first angle times the cosine of our second plus the cosine of the first times the sine of the second. So this is equivalent to that. Okay, so I'll let you, if you want to just practice, you can try that number 2 out. I want to show you one more, and I will post all of these online. This is just, you're not going to have like a homework assignment tonight. The homework is just to get this note sheet looked at and figured out. So it's kind of neat to see how this works. So if I look at number 3, we're going to do this one together, and then I'll let you do the rest on your own. The sine of pi minus pi over 2. We know what both of these are, so we don't. Ignore that. We know we can combine these terms. I guess that's what I'm trying to say. Pi minus pi over 2 is pi over 2, right? We think about this as like 2 pi over 2 if we get a common denominator. So the sine of pi minus pi over 2 is the same thing as just the sine of pi over 2 if I were to just combine those terms. We know the sine of pi over 2 is 1. So we can see this thing in action. It's kind of neat to see how this works out. So this is the sine of a minus b formula. So to break that out, this becomes sine a cos b. So notice right there, that's a really important point. The b is just this, right? The minus sign doesn't come with it. The minus sign is built into the identity. All right, so hopefully that makes sense. It's just the cosine of a minus, the sine of a minus b. The a is pi, the b is pi over 2. It's kind of like the sum and difference of cubes that we did at the beginning of the year. The minus sign is built into the function. So we have sine a cos b minus cos a sine b. And those are exact values that we learned, a long time ago when we were actually together. So the sine of pi is 1, and this is what you can go back to your old notes to look up. The cosine, I'm backwards. The sine of pi is 0. The cosine of pi over 2 is 0. The cosine of pi is negative 1. And the sine of pi over 2 is positive 1. So we have 0 minus a negative 1, which is 1. So interestingly enough, that checks. It comes out to what it should be. We know the sine of pi over 2 is 1, and then this whole long identity gives us the same answer. Okay, so if you want to play around with the rest of these, I have them all done. I'll post these notes online. Quick note on number 8. No, not number 8. I'm thinking about the next page. Anyway, try those out, play around with them, see how you do. Next page. Similar idea. I just kind of gave us the combined value. So we don't know the sine of 75 degrees. But we do know the sine of 45 and 30. So I could take this 75 and I could turn it into 45 plus 30. I could also do, I could do 105 minus 30. So I don't have to just be in quadrant 1. I could do any combination as long as it's the exact values that we know. So I'm just going to rewrite that 75 differently. And now we just go to our formula again. So the sine of 75 can be rewritten as the sine of 45 plus 30. There's my A and there's my B. So my formula is sine A cos B plus cos A sine B. So I'm going to pause and work through this. You guys can try it out on your own, and then we'll come back together in a second. So when I unpause, my work will all be there. So try it out now. Okay, so breaking this out, we have sine A cos B plus cos A sine B. Those exact values. Just go back to your chart, go back to your notes. I don't care if you have these memorized right now, but I can plug those values in. We multiply our fractions using our radical strategies, our fraction strategies, and there's my answer. Okay, so I'm going to put all these notes up there. Just keep in mind, I can get to 105 a few different ways. So I could do, 60 plus 45. I could do 135 minus 30, as long as it's exact values that you know how to find. And just keep in mind the quadrants that you're in also. Okay, you don't have to do all these. There's a lot here. When you get down to number 6, you will have to rationalize a denominator. So when you get to those, check those notes out. You may need to pop into a Zoom meeting or send me an email on this stuff, but it's pretty straightforward. We just need to figure out what angles we can use to find those values. Next page. Here we kind of are just working backwards on this one. This one's not too crazy, and it looks funny, but looking at this pattern, we kind of think about this as our A, this is our B, and then we have the A and the B again. So this is a cos A, cos B, minus sine A, sine B pattern. And then we just use these as our A's and B's. So when we have a cos A, cos B minus sine A, sine B pattern, this is the cosine of A plus B formula. So the cosine of A plus B, and then we just have to add the A and the B together. So 2 pi over 5 plus pi over 3. Okay? I'll put that answer online. Don't stress that one too much. Here's the last thing you're going to see, and there's a little more to this. So what I want you to do on your own, we did this a lot earlier in the year. We're going to first kind of sketch what these two angles would look like. So I'll get you set up, then I'm going to have you pause and work on it on your own for a minute. But we know the sine of angle A. So we'll call this my angle A diagram, and this my angle B diagram. The sine of angle A is 4 over 5. So the sine we know is opposite over hypotenuse. Cosine we know is adjacent over hypotenuse. We know angle A is in quadrant 2, and angle B is in quadrant 1. So this is where we would kind of construct those angles. So why don't you pause, and I'm going to do that now just to save some time, and then we'll come back together in a second. Pause now. All right, so there's my triangles. Hopefully we remember how to do this. Quadrant 2 for angle A. I know the opposite and the hypotenuse is 4 over 5. Pythagorean theorem, I gave you a nice easy triangle. We know that's -3 because we're in quadrant 2 and the x value is negative. Same thing for angle B. The cosine was adjacent over hypotenuse. I found the missing side to be 5. So now I have my two triangles drawn. And to find the tangent of A plus B, remember this is not just the tangent of A plus the tangent of B. It's not that easy. We have to expand using the identity that I showed you. So at this point we have our formula. I'm going to pause again so you guys can finish this up on your own. But now that I have this broken out, I just write it all out. So the tangent of A is just the opposite over the adjacent of angle A. So I'm going to write all these. We have a little complex fraction work to do, but I have faith that we can do it. So go ahead and work through this. I will unpause when I'm done. You can walk through my work, and then we'll wrap it up. All right, pause now. Okay, so home stretch. I plugged in all the stuff I knew, tan A, tan B, 1 minus tan A, tan B, keeping in mind that negative sign for my tan A value. I multiplied those fractions down here to give us that 20 over 36. And then at that point, you guys know me, I like to simplify using our complex fraction strategy. So I know everything here, the overall common denominator is 36. So then I kind of start thinking about, what divides out, what stays. So here we have the 12 left over. Here we have, times 3, so on and so forth. So that is hopefully making sense to you guys when this divides out with the 36 here. That's how I have the 20. And I'm left with negative 33 over 56. So a lot of work there. I'm going to show you the next one on the notes. Your only homework is to walk through these notes, try out some of the examples that I left blank, come to the Zoom meeting if you need to, and then next class, which will be Wednesday, we'll do the problem set that goes along with this. So hopefully that will kind of tie up the loose ends. All right, thanks for bearing with me, a little longer video, but next class hopefully will be nice and short. All right, I'll talk to you guys soon.